Hi, good morning everyone. Today we are going to learn first chapter of heat concept, that is thermal properties of matter. This is Sachin sir. First we will learn how to convert temperature from one scale to another scale. We have actually three scales. One is degree Celsius, another one is Kelvin, and last one is Fahrenheit. See, in today's class we will learn about thermal properties of matter synopsis. In the next class we will learn kinetic theory of gases synopsis. In the third class we will see problems from both thermal properties of matter and kinetic theory of gases, and after that we will separately see thermodynamics, because there are two questions appearing in competitive exams from thermodynamics, one from thermal properties and probably one from kinetic theory of gases. Since both of them are having less point coverage and hour coverage, we will do both kinetic theory of gases and the thermal properties of matter together. Okay, see, first of all we will see conversion of temperature from one scale to other scale. We have C minus 0. C refers to degree Celsius, F refers to Fahrenheit, and K refers to Kelvin scale. This will be C minus 0 divided by 100, F minus 32 divided by 180, and K minus 273 divided by 100. This is because 180, because from freezing point to boiling point, Fahrenheit scale is divided into 180 parts, whereas Kelvin scale is divided into 100 and degree Celsius scale is divided into 100 parts. Okay, to convert Fahrenheit scale into degree Celsius scale, we have formula TF is equal to 9 by 5 into TC plus 32. Okay, to convert TC into TK, suppose we have 35 degree Celsius temperature, that is in TC. I have to convert it into Kelvin temperature. For that I have to add 273, that you people know from your studies in you people know that your studies in from your studies in high school days and first year PUC, that is 35 into 273 is a 298 Kelvin. So sorry, it is a 308 Kelvin. So that will be your temperature. Okay, for example we will see one more problem. Express this will be this is NCERT model paper problem. Express 60-degree Fahrenheit in degree Celsius and also in Kelvin. Okay, in Fahrenheit we have 60-degree Kelvin. I have to convert it into degree Celsius and also in Kelvin. First I have to write degree Celsius and Fahrenheit scale relation, that is TF is equal to 9 by 5 into TC plus 32. That will be TC I have to calculate, that is degree Celsius. It will be TF minus 32. I have to take this 32 to the left side. This will be TF minus 32, and this 5 by 9, this 9 by 5 will become 5 by 9. So this is 5 by 9. TF is how much? TF is 60-degree they have given, minus 32. 60 minus 32 is 28. This will be 5 by 9 into 28. 5 8s are 40. This will be 140 divided by 9. 59s are 135. So answer will be 15.55 degree Celsius, because it is Celsius scale. Now we also have to convert it into Kelvin scale. Since TC we got 15.55.3, how to convert into it into Kelvin scale? We have to add 273 to the 55 degree Celsius. So 273 15 becomes a 288.55 degrees Celsius, isn't it? This will be answer in Kelvin. To convert Kelvin into degree Celsius, we have to add we have to operate with the 273, whereas to convert TF into TC, 9 by 5 TC plus 32 is the method. Okay, next homework for today is learn about absolute zero point, freezing point, boiling point in all the three scales, that is Celsius scale, Kelvin scale, and also Fahrenheit scale. Okay, Celsius scale, Kelvin scale, Fahrenheit scale. You have to learn about absolute zero, ice point, and freezing point conditions. Okay, so to convert one scale to other scale in thermal properties of matter, we have this formula: C minus 0 by 100 is equal to F minus 32 by 180. K minus 273 by 100. To convert TF into TC, we have this formula. TF is equal to 9 by 5 TC plus 32. To convert TK into TC, we have, that is Kelvin to Celsius, we have TK is equal to TC plus 273. Please take the screenshot or pause the video. You will get the idea and learn it better with the NCERT textbook and some other NCERT JEE NEET textbooks and also KCET textbooks. Okay, or pause the video or just take the screenshot. You will get the better understanding. Now let us move on to next concept, that is concept in thermometry. Conversion of one thermometer reading into another thermometer reading. Okay, this is basic, you have to understand, very simple. You have two scales. What is the meaning of this expression or this formula? You have two scales. One is your noun scale, another one is your unknown scale. Okay, you are measuring the same temperature of the same body in both noun scale and unknown scale. They may give temperature measured in noun scale and its freezing point and its boiling point, that is lower point and upper point in this scale. They may ask what is temperature in unknown scale by giving its lower point and upper point, that is freezing point and boiling point. Okay, we will see the formula. To convert one thermometer into another thermometer, we will have this condition. When you solve a problem, you will get a better idea. Temperature on noun scale minus lower point in the sense freezing point. Degree Celsius, it becomes 0 degree Celsius. In Fahrenheit it becomes 32 Kelvin, and in case of Kelvin it becomes 273. Okay, upper point minus lower point. Temperature on the noun scale minus lower point divided by upper point minus lower point, that is boiling point minus freezing point, is equal to temperature on unknown scale minus freezing point, low point, divided by upper point minus lower point, or boiling point minus lower point. Okay, this is our condition. Temperature on noun scale minus lower point divided by upper point minus lower point. Temperature on unknown scale minus lower point divided by upper point minus lower point. On a new scale called as X scale. X scale means unknown scale, isn't it? Boiling point and upper point, boiling point and freezing point are called to be 239 degree K X and 39 degree X. Okay, temperature, this is temperature of noun scale or unknown scale. X means we don't know which scale it is, so I have to write respectively what will be the temperature on new scale. Okay, the temperature on new scale, they are asking new scale in the sense unknown scale. Okay, I will take it as Y, temperature of unknown scale, minus lower point, what they have given, 39, isn't it, divided by upper point, they have given it as 239, minus lower point, again they have given as 39, respectively. What will be the temperature on the new scale, that is Y, I have to calculate when same temperature is measured to be 39 degree Celsius in Celsius scale. See, they have given temperature of the same condition, same observation in Celsius scale, that is 39, isn't it? 39 minus what is lower point on Celsius scale, that will be 0 degree Celsius, divided by what is upper point in Celsius scale, that will be 100, minus again what is lower point, 0. That becomes you get from this equation, you get 39 by 100 is equal to Y minus 39 divided by 239 minus 39 is 200. Okay, you have to calculate what is Y. You have to calculate what is Y, and you will get the formula. Okay, suppose this thermometry formula helps us to calculate temperature of the same condition. When you know the temperature of the same condition at a different scale, you can calculate in another scale. Probably its freezing point and lower point is known. Okay, so that is the thing. You can understand the following formula, and you will get the better understanding of this formula. Okay. Yes, the homework, as I told before, you have to calculate lower point, freezing point, boiling point, and also absolute zero conditions and upper limit conditions, that is boiling point usually, for Celsius scale, Fahrenheit scale, and Kelvin scale. Okay, just to see the formula, you'll get the idea. Okay, you see the formula, just take the screenshot and solve this problem, you'll get the better understanding. Okay, thank you. Next we will move on to next concept. that is expansion, thermal expansion, one of the behavior when a body gets heated up, it expands. Okay, that is suppose you have length L for a body. When your temperature is given, its length becomes L plus delta L. Its length becomes L plus delta L. The change in length divided by original length is directly proportional to change in temperature, because this change in temperature is producing this variation in length. So delta L is directly proportional to L into delta L. If I remove proportionality symbol, I will get length temperature coefficient lambda L, sorry, alpha L, alpha L into L into delta T is equal to delta L. Okay, what is delta T? Delta T is final temperature minus initial temperature. Okay, so if you add this delta L to the initial, it becomes final length is equal to initial length alpha L into delta T is TF minus TI, isn't it? This is a condition. See, in the area expansion, we have change in area divided by original area will be directly proportional to change in temperature. Delta A will be directly proportional to A into delta T. If I remove proportionality symbol, I will get alpha A into delta T. So final area will be initial area plus change in area. So final area will be AI. This change in area is alpha A into delta T. Okay, this is a condition. In the similar way, change in volume by original volume is equal directly proportional to delta T. Change in volume is directly proportional to alpha V into delta T. Change in volume is volume into alpha V into delta T. So final volume is equal to initial volume plus change in volume. So final volume is equal to Vi plus V into alpha